Good day, everybody. How are you all doing? This is Dr. Nandi. Today, we are going to talk about the salient features of catalyst and reaction rate law. So I'll share my computer screen with you. So catalyst and reaction rate law. First, we define what is a catalyst. A catalyst is a chemical substance that increases the rate of a chemical reaction. For a chemical reaction to take place successfully, the reactant chemicals must react by overcoming an activation energy barrier. A catalyst lowers the activation energy but does not alter the energies of reactants or products. A catalyst speeds up a chemical reaction by providing a set of chemical steps with more favorable kinetics than those that exist in its absence. An example of a catalyst used in a chemical reaction is a small amount of manganese dioxide used in the production of oxygen from the thermal decomposition of potassium chloride. Half-life of a reaction. A measure of the rate of reaction relating concentration to time is half-life, T subscript half, which is a time required for the concentration of a reactant to decrease to half of its initial concentration. An analogy of half-life is if a college student takes 4 years to graduate, the half-life of his or her stay at the college is 2 years. Thus, half-life of a student in the college is not affected by how many other students are present. Similarly, the half-life of a first-order reaction is concentration independent. A first-order reaction is one in which the reaction rate is proportional to the concentration of the reactant. The average rate of reaction is the change in concentration of a reactant divided by change in time. Because the concentration of the reactant, that is the chemical which is reacting, decreases during the time interval, the change in reactant is a negative quantity. The average rate of a reaction is a positive quantity. So a minus sign is needed in the average rate expression to make the average rate positive. This is because the decrease in reactant is negative. So to express the average rate of reaction, we put a negative sign in front of it because two negatives will make it positive. The rate law. The rate law expresses the relationship of the role of the rate of a reaction to the rate constant and the concentration of the reactant raised to some powers. So it's a relationship of the rate of reaction to rate constant and the concentration of the reactant, which will be raised to some powers. For the reaction A, capital A, and B, capital B, reacting together. So capital A is the one reactant, capital B is another reactant. A and B are stoichiometric coefficients, giving, after reacting, they produce C molecules of capital C product and small d molecules of capital D. The rate law takes the form rate equal to K multiplied by concentration of A raised to the power of X multiplied by concentration of B raised to the power of Y, where X and Y are the numbers that must be determined experimentally and K is the rate constant term. For the reaction where A molecules of capital A reacts with small b molecules of capital B, producing small c molecules of capital C and small d molecules of capital D, the rate is given as K A exponent X multiplied by B exponent Y, where X and Y are not equal to the stoichiometric coefficients small a and small b. The exponents x and y specify the relationship between the concentration of reactants A and B and the reaction rate. So the exponents x and y added together give us the overall order defined as the sum of the powers to which all the reactant reacts. So I'll stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. If you like this video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And I'll be back next time with another interesting concept. Thanks for watching. Take care. Have a nice day. See you later.